Good morning, ladies and gentlemen. Thank you, Mr. Gulati, for those kind words. Now, let me do the honors of inviting our key panelists for this discussion. I'm joined with a very august panel of members who will be joining me on this panel discussion. To start with, can I request Mr. Amrit Manwani to come and occupy the chair, please? Mr. Manwani Saab is an engineering graduate from IIT Kanpur and MBA from FMS Delhi. He is a known face in the Indian electronic industry. He's worked with different organizations and he has started his own business in 1991. He's the chairman and managing director of Sahasra group of companies. He is the past president of ELCINA and 2 times, I would rather say that. And apart from ELCINA, he has also been associated with many other organizations and associations. He was also the managing director of Tegna EMC cluster in Greater Noida. He is the chairman of ELCINA EMC cluster in Bhiwadi in Rajasthan, and he is also the vice chairman of the board of Electronic Sector Skill Council of India. So, thank you, sir. Thanks for joining. Look forward to the discussion. The next, I have the pleasure of inviting Mr. Pankaj Gulati to the stage, please. So we all have been listening to Mr. Gulati's excellent comparing since morning. Thank you, sir. A brief introduction to Mr. Gulati. He has over 40 years of working in the semiconductor business in India. And he's the CEO of CDIL. We have their stall here right away. And he is also the past president of ELCINA. He's traveled widely across the world, and he's involved in the complete value chain of the semiconductors, I would say, right from starting from manufacturing, R&D, to sales and marketing, and doing this. So he's a very encouraging person, and I've known him for some time. It's my honor to have you on the stage, sir. Thank you. My next panel member is Mr. Arshi Krishnachar. He is the Group Vice President of Seoul Semiconductors. Please come and occupy your chair, sir. Mr. Arshi Krishnachar has over 2 decades of experience in the Indian industry. He was earlier with Philips. He is now the Group Vice President of Seoul Semiconductors. He is also the Chairman of Indian Society of Lighting Engineers. He is also an Executive Board Member of Asian Community Network, essentially consisting of expatriates from Korea, Japan, Vietnam, India, and Taiwan. And Mr. Arshi's passion, apart from selling LED chips, is also to guide a lot of young people getting into diverse kind of businesses. So he has been working on the social cause there as well. So it's my pleasure to be discussing with this group. We are discussing a very interesting topic, which is, I think, is one of the hot topics going around in the country today in terms of the semiconductors and how can we build a semiconductor ecosystem. While many of you all will know that semiconductor is actually touching all our lives and every aspect of our life, it is a $400 billion business currently worldwide. That's likely to become a $1 trillion business by 2030. India is relatively a very, very small market compared to the global market for semiconductors. We are about $15 to $17 billion currently. And the kind of plans we have for electronics manufacturing will reach anywhere between $65 to $75 billion by 2025. Even that is a sizable business opportunity, and that needs to be tapped. And as was in the inaugural session we heard, we seem to have missed the bus in the earlier 2-3 decades. But now I think this is the time to board this train and make sure we arrive at a very healthy speed in the semiconductor journey. So this discussion is all about how do we go on the semiconductor journey. The government is pushing the industry very aggressively. They are interested. They are willing to listen. So in this session, we will discuss in terms of what is it that can be done in India, what are those low-hanging fruits which Indian industry can address, how it can be addressed, and what are the policy support and requests from the government of India and also from the industry to make this semiconductor ecosystem creation a possibility. That is the broad objective of this panel discussion. So the way we'll conduct this panel discussion is I will have an opening remarks from each of my speakers for a couple of minutes. And then I have a set of questions which I will engage them in discussion. And then I'll take your questions. Right? So, Mr. Manwani, if you can kindly give your opening remark, please.
Can you hear me? Yeah. Okay. Thank you, Dave, for your kind introduction. And good morning to all the delegates who are here present today, ladies and gentlemen. I'm thankful to ELCINA for giving me this opportunity to share my experience on about the semiconductor industry and how semiconductor industry is likely to grow in the country in the next 3 to 5 years. As they've just mentioned, the total market for semiconductors in the country as of today is roughly about 1.1 lakh crores, which is likely to grow at least 4 times to about 4 lakh crores by 25-26. Now that's a very tall task in the sense that not only as per the current global scenario, there is tremendous shortage of semiconductors. So, and with the demand going up 4 times, how we are going to meet that, that's a big challenge. And therefore, considering that, we definitely have to look at developing an ecosystem in the country so that our import dependence is reduced to the extent possible. With that, I would just briefly like to mention that, what we are doing. Firstly, as in the morning session, it was mentioned that electronics is all pervasive. Similarly, semiconductors is like the backbone of the electronic industry, and therefore semiconductors are required across the entire industry domain, be it electrical vehicles, be it mobile phones, be it memory products, data centers, consumer electronics, defense electronics, and so on and so forth. So it's a very vast field, and what we have done, for example, at Sahasra, we have set up a new project called Sahasra Semiconductors, and this is in Bhiwadi, Rajasthan, and we will be only focusing on the memory segment because unless you are very specifically focused, you will not be able to develop what you are setting out to do. So even in the memory space, what we are looking at is, because memory space by itself is very large segment. To give you an idea, last year, the country of India imported memories in variety of products, be it SSDs or USBs or pen drives or even for data centers and other products, about in excess of $1 billion, for about 10,000 crores worth of memories were imported in the country. So with that in mind, we have focused our project towards memories, and even in memories, we are focusing mainly on NAND flash memories and the drivers or the microcontrollers which drive the memory. So we would be focusing on packaging of ICs which are in the NAND flash memory domain and the controllers that drive the flash memories. So these are my initial remarks, and I would now give it to...
Thank you, sir. Mr. Gulati, if you could.
Thank you. Hi, good afternoon, everybody. Just a brief. My background is MSc Physics, and then semiconductors, MTech in semiconductors. And I've been in this industry for 40 plus years. Fortunate to work with one of the only surviving semiconductor companies in India, CDIL, Continental Device. And also fortunate to have many friends and guide and seniors here, starting with Mr. Sanjeev Narayan, Mr. S.K. Gupta. All of them have been my guide and my teachers during the last 40 years of my experience. As a company, CDIL is into the semiconductor components on the lower end, I would say, not the nanometers or the submicron technology. We are into the discrete semiconductor components, which is also a very important critical part of any electronic circuit. And as a company, we've been initially also had wafer fab a lot of you may not be aware of it, but we ran our own wafer fabrication from 1971 till 2008. Then when we started to tone down the fab because of the not so conducive government policies. We are thinking again on that, but that's separately. We are now expanding and growing in the discrete semiconductor area, which is on the surface mount side, which is where the focus on the technology is going, on the SMA packages, SMB packages, DPACs. All this is under the PLI in the spec scheme, which we are approved under. Our plants are at Mohali and New Delhi, and it will be very interesting, and I appreciate ELCINA to call me for this session, and wonderful to have Dev as our host. Thank you.
Thank you, sir. Thank you. Mr. Arshi, if I could request you to give your opening remarks, please.
Yes. Good afternoon to everybody. Thank you very much for good words by Mr. Devendranath about me, and thanks to ELCINA for having me here. Semiconductor, as Pankaj has said, is a very wide spectrum. We as a Seoul Semiconductor are into the compound phosphorus of manufacturing LED discrete packages, and this is a very interesting and a very large business. In India, for the last 2 decades, when the disruptive transformation from a mercury to a halogen to LED has converted, India has never able to find, at least to make an assembly or a package so far till date. So there is a huge opportunity for the EMS and OEM companies who can able to collaborate with this company, especially with us, where we are looking to partner and share our technology. To begin with is a package. Later on we can progress into a chip as well as EFAB and FAB. So over the discourse of discussion, we can able to explore how this opportunity can materialize and try to bring some kind of a synergy in terms of identifying the talent, application, as well as technology as a collaboration to make some kind of an ecosystem which can make it happen in India, can make and try to first is to the India market and then to the neighboring market. Afterwards, of course, we have an export market. If you look at the market size of the LED package only as a lighting industry globally is more than 30 to 40 billion US dollars. And if you look at the other applications, which is IT, mobile, then UV, automotive, huge applications can be tapped. So it's a time for all of us to gather and try to bring some kind of a synergy. However, we have to depend technology from these countries, especially from Korea, Vietnam, and of course, Taiwan, how we can able to collaborate and start having it. It's a high time all of us has to find and try to set our balls rolling. With this, I will leave the note probably over the things we can take it forward.
Thank you, Arshi. Appreciate it. Okay, let's get into our discussion now, which is of interest to all of y'all. So, in our initial remarks itself, you would have noticed that Mr. Manwani spoke about flash memory, and Arshi spoke about LED chips, and Gulati Saab spoke about different kinds of surface-mounted devices, etc. So semiconductors is actually a very vast subject. Different types exist here, and each one would require a different kind of an ecosystem. So to begin with, before we understand what can be done in India, I would like Mr. Gulati to set out in simple terms to the audience here in terms of what are the different types of semiconductors and what does a semiconductor ecosystem mean? How does it differ for different types of semiconductors? How is it, sir?
Thank you. Sorry, I keep bothering you. Okay, as I was trying to express in my initial comments, semiconductors as a family is a very, very wide spectrum of products, starting from whether it's VLSI, memory chips, what Amrit is going to do, microprocessors, down to a simple one-junction diode. This is all semiconductors. Now, earlier the semiconductors were restricted to initially gallium arsenide, then silicon, but now you even have wide band semiconductors, you even have silicon carbide. So there are a lot of semiconductors. When you say semiconductors, it means many areas, many segments of products are covered. This is the family. Now when you come down to assembly, now even in an assembly of semiconductors, there are various various packages. If you open your own board, you must be using a lot of electronic boards. You will find you will have simple diode 2-lead package going up to the QFN, DFN packages, which is the quad no-lead package, the dual no-lead packages. Then you have flip chips, and then various packages are involving. Now, each of these packages have a different assembly technology. It's not that every semiconductor is made of the same assembly technology. Flip chip is made in a different way, QFN assembly is done in a different way, and a discrete semiconductor assembly is done in a very different way. Silicon carbide has its own issues of dicing, brittle wafers. So every semiconductor has its own set of requirements for assembly. Coming down further, deeper into the value chain is the wafer fabrication, which itself is also a huge investment, and possibly everything is not different in there, but some set of tools are different for different types of families and products that we will manufacture. So when everybody says that we need to manufacture semiconductors, I think there needs to be a little bit of focus on what has to be done in semiconductors. What area are we going to focus on semiconductors? Like Manwani sir has said that we will do memory. So it's a focus. So you know in memory I need this, and you go about it. Similarly, with the promotion schemes coming from the government, go into semiconductors, whichever company wants to venture out, we look at semiconductors and then try to focus. Now answering Dev's question is, what about the ecosystem? Is it different or is it similar? The equipment these days is very dedicated, the assembly equipment. I'm not even going to the wafer fab. That's a very different ballgame. We'll discuss that later during the session. The assembly equipment is quite different for different type of semiconductors. It's a dedicated equipment. If tomorrow Mr. Krishnajar says, I want to assemble my LED chip into Mr. Manwani's assembly line, it's not going to happen. It's a very, very different type of equipment, and it has its own requirements, own set of rules, own set of processes. So it's a very, for each semiconductor, there'll be a different requirement of different assembly lines. Something that is common, that probably most of the semiconductors use is the lead frames, some of the bonding wires, some of the molding compounds. Yes, lead frame designs are very different, but the technology, whether it's a stamp technology or an etch technology, very similar and can be used in various product ranges. So in the ecosystem, when we talk of the down the line ecosystem, in the materials, there could be some similarity, but in terms of assembly lines, I would say that each semiconductor requires a very dedicated set of equipment. Was that right? Thank you.
I think it's, thanks for that clarity in terms of what it is. Now, taking a cue from what Mr. Gulati set out, as we all know, there are different types of semiconductors and each one requires a different kind of an ecosystem to be created. Let me take this question forward and ask all my panelists one by one to set out their idea of what is ideal for India. Right now, because since we are starting on a clean slate literally in semiconductors, so what are those low-hanging fruits as per you, sir? Mr. Manwani first.
Thank you, Dev. Well, again, as I said earlier, that I will focus more on memories. In memories, definitely a lot of low-hanging fruits available. For example, in the country of India today, as I said earlier, there are all the memories that are used either in, through the micro SD cards that we put in our mobile phones, or we put in some equipment. That is a huge demand. Similarly, the pen drives themselves, the USBs, as we know, we call them pen drives. So they have a huge demand of memories, both for the memories as well as the drivers. So these are really very low-hanging fruits, and that is where we could focus. As I said earlier, that the total demand for all memories in the country is about 10,000 crores. Of course, some of them are high-end. For example, the eMMCs that go into mobile phones or data servers, those are a little bit high-end, so we should not look at that in the initial stage. Also, the technology level that is required to package those kind of ICs or semiconductors is advanced. So we have to take some baby steps first. So as I said, perhaps what we should do is look at micro SDs and COB kind of products, which have a huge demand in the country. Today, everything is being imported from Southeast Asia, whether it is Singapore or Taiwan or of course China, Korea, and even countries like Thailand and Philippines. If we could make them here, our import dependence will be reduced to that extent. And I think with volume, it's definitely a low-hanging fruit. But the other point that I wish to make is that if we start making volume, there will be a great opportunity for us to export these products to some of the emerging economies or emerging markets like Middle East and Africa, and even Latin America.
Right. In fact, just taking a cue from the earlier discussion where a lot was spoken about the automobile ecosystem, like India is a world's largest exporter of the small cars. So within the semiconductor ecosystem, Mr. Arshi, do you think there are any such opportunities where India can capitalize on, and what are the low-hanging fruits as per you?
I would rather say, rather than low-hanging fruits, I will focus more on the high-hanging fruits, probably on the LED package. India is a matured in terms of application as far as the lighting industry is concerned, or the LED package for lighting, IT, automobile, and UV applications. There is a huge opportunity to materialize that. As Mr. Manwani said, the dependence is completely on the Southeast Asian countries. How do we bring that to make it happen here? The first and foremost is a semiconductor, as I said, is a very vast industry, and to equate what is semiconductors is, it is more of a fundamental electronics. So going beyond this, to restrict ourselves to begin with, we have to identify the companies, the EMS or the OEM companies who can show the expression of interest, at least to begin with, packaging and assembling. At least the chips, raw materials still start coming from the Southeast Asian countries. We try to know how do we assemble, how do we make, how do we do the kitting, and then how do we package and sell it to the Indian market. If that itself is done, our net, at least out of 3 billion, 1 billion business comes to India and generates that revenue to India. So this is where from the government side as well as from the industry side, to bring the synergy in terms of the equipments, in terms of the labor, in terms of skilled labor in producing, handling, and trying to see the complete ecosystem of the supply chain as well as quality is maintained. If we try to bring some kind of a system in its place through this kind of systems, and government also takes the lead along with this, the companies who are interested, going to those companies which are already making them and have some kind of a memorandum of understanding done, and that is where we can take it forward. That's what
Right. Thank you, sir. Thank you. Gulati sir, according to you, apart from what the two other gentlemen have spoken about, what are your ideas about the low-hanging fruits for a country like India?
Thank you, sir. I agree to what my friends here on the dais said. I would just like to add a few things in this. I think what we need to do is we should start, or India should get into those semiconductors where there is definitely a domestic market availability to begin with. We have to get into manufacturing those components which are in demand in India to a certain extent, and then grow on that demand and establish ourselves with the volume to export. Fortunately, CDIL as a company, we've been exporting for 35, 40 years. So, and believe me, that helps, because the export market demands a certain quality, demands a certain service, and that helps. So for us, when we manufacture on a production line, we do not know whether the product is going to the domestic or export. And so the domestic customers, initially, now the domestic customers are very conscious, quality conscious, but I'm talking 20, 25 years back, they were getting the same product quality that we were exporting to Europe, to US, or any other Southeast Asian country. So coming back to the low-hanging fruits or whatever is available, my feeling is that we should get into areas like electric vehicles, energy meters, the white goods. Every EMS company that we now talk to, where we hear in the morning also, every EMC company needs a support on the components in India. So let's try and see what type of components are going to be in demand in various organizations, sectors, segments, and then look at those segments, try and combine that, start a manufacturing line into that segment, and then grow onto it and add exports to it. And that's the way to go that I feel in my experience for the last 25, 30 years. Thank you.
Brilliant, sir. So, gentlemen of the panel, if I can summarize this first topic which I took in terms of the low-hanging fruits, can we then say that memories, LED chips, and power devices would be the low-hanging fruits from an Indian market demand perspective?
Yeah, absolutely. In fact, what I would say, I don't want to steal your domain, but apart from LED chip, there are, other semiconductors which, for example, drive the LED chip. So the LED driver chip could be a very large volume business in the country. It's simpler to make. There's a huge volume. See, India today is, leading in terms of LED light manufacturing. So, every LED that or LED engine, as you call it, light engine, will have to have a driver.
Yeah.
In India itself, there's an annual demand of about 120 crores units of LED driver chips.
Wow.
So, these are the low-hanging fruits. And, I was a little surprised. I'm just a little bit digressing, but I was a little surprised that in the next round of in the India Semiconductor mission that was announced last month, only 4 companies came out to participate in the scheme for semiconductor packaging or ATMP or OSAT packaging. I would expect that there is a potential for at least 10 to 15 more companies.
Absolutely.
That's the kind of demand that is there.
Absolutely. I'm sure post many sessions like this, the companies, Indian companies would be confident enough to take a part in this ecosystem and come forward. Thank you, gentlemen. Thank you. Now, moving to the next thing which I have in mind is, while fabs are still some years away, how can we address the semiconductor ecosystem immediately? Mr. Manwani?
Well, this will be a big challenge because as of today, there is virtually no ecosystem in place. As Pankaj also mentioned, that everything from substrate to wires, the interconnecting wires, or molding compounds, or the die-attach resins, everything is imported in the country, including, of course, the main giant thing in this is, or the elephant in this thing is the wafer itself. That is not available, and so we will have to initially depend on all our raw materials from overseas. But we have to take steps to at least start the simpler raw materials, whether it is the wire. Typically, you have the gold wire or the aluminum wire or the copper wire. So those could be perhaps made in the country. Similarly, some of the molding compounds, etc. From raw material point of view, we could leave the fab aside because that's a different scenario altogether. But all the other materials, including substrates, because substrates is nothing more than specified PCB. Why can't those be made in the country? So that is on the raw material side. But what is very important is that today, again, all the equipment that is required for semiconductor manufacturing is again imported. And there are only few countries that make it. It's Korea, Japan, Taiwan to a certain extent, China, of course, and mainly these countries. The problem is, because of this semiconductor shortage that is currently prevailing in the world, the lead time for these equipments have skyrocketed. What was being quoted before the shortage began, what was being quoted for delivery of 12 to 14 weeks, today we are hearing delivery of 13 to 14 months.
Wow.
So, if I decide to procure an equipment, whether it is back grinding or whether it is wire bonders. Wire bonders is such a simple item in this equipment chain, but the wire bonders are not available for anything less than 32 weeks. So be that as it may, at least what we can do is the after-sale service that we have to develop very quickly. The sales representatives who represent these companies, they should have a strong service network. That is the need of the hour. We cannot afford, once the packaging industry comes in, we cannot afford to have downtimes. And those downtimes can be avoided if we have a good after-sales service setup. Once that is established, then obviously the likes of Discos or the likes of KNS or other equipment manufacturers would definitely look at India as a manufacturing location.
Thank you, sir. Thank you. Very elaborate. Mr. Krishnachar, I'd like to ask you, since you represent an international firm in India, what are the learnings for the Indian industry and the government of India to take from developed countries like Korea in terms of how they have evolved their semiconductor ecosystem?
Yeah, so at least I had to start with a little note. We are at least more than 1.5 decades behind all these countries. So now, as Mr. Manwani said, the need of the hour and a long-term perspective. So when are we going to start? It's the time to start. How do we start? To start is all dependence from the lead length to the bonding wire and the golden plates. All we have to depend on them. However, still we have to depend. We have to have a collaboration to have the at least assembly and packaging unit to have it. That business comes back to India. That's what I have been emphasizing again and again. Whatever is, we do not have any control on them. If the machine is shuts down, we have to wait for them to come back and then address it. We don't know how to even open it also. That is where we are standing. So the learning is, we have to have a collaboration with them. The skilled team, the skilled entire production team comes here and support us and try to first is the domestic market. They don't allow us to go to the other European markets until unless we cater to the Indian market. India itself by nature is a big consumption market, be it a lighting, be it IT, be it an automotive. If that itself is catered and serviced to them, we can show the confidence, we can learn, we get a hands-on experience to proceed, and then they also get a confidence. They started, trying to share more information and more things like that which can help us to understand and try to be indigenous by ourselves even after 5 or 10 years. So we have to kickstart. That's where is the most important thing from my side.
Thank you. Thank you, Arshi. Gulati sir, one last question from my side and then I'll open up for the audience questions as we are approaching this. Apart from the semiconductor PLI policy, which the government has bought in, what are the other, what I'd call it as policy recommendations you would have as a semiconductor person for the government of India to look at?
Thank you, sir. I think there are, as of now, in the last 1 year or so, sufficient policy incentives and measures have been brought out. I now believe it's time for the industry to move on and show some action. We as an industry can't keep asking for more incentives, more policies, unless we actually move on and take it on ourselves to move. And now, the reason semiconductors or most of this is not being manufactured is, I think, probably in the morning you would have heard of ITA 1, and that was the block which stopped most of the companies in India to manufacture because it came under zero duty regime. But there are certain segments that when you say that what we request, possibility when this ITA 1 was brought out, there was no really an LED lighting segment or sector at that point of time. Like mobile phones, can the LED be moved out from the ITA 1 and can we impose a custom tax on the, what Manwani sir said or what Krishna, on the LED drivers? Because LED driver is a large market. It's assembled in the SOP 8 package. Let's start the assembly lines, ATMP lines or OSAT for LED drivers and try and cover that up. Just putting a 10% or a 15% hindrance tax or some sort of a thing by the government provided it doesn't clash with the ITA1, which I believe we can possibly make a case of it being that LED was not even existing when this ITA was brought into the picture. So things like this is small areas. Secondly, what Mr. Krishnachar has actually touched upon a point which has always been very dear to me. Most of the international companies would like to come into India and find strategic partners. And it's time for us now to show that we have the ability to absorb those partnerships, the technology, the ability to manufacture. And I will request companies like Seoul Semi and other similar companies, if they are in this room, move forward, come to us as an ELCINA also and as an individual industry members, talk to us. We have the ability to manufacture for so many years, and we can possibly work together, not only for the India, but for the export market, whether it's Africa or Europe or US, whatever sectors they are. So these are, and coming back to your question, I think it's not very right for us to go back and keep asking more incentives and more policies from the government. What we need is, in the morning, what Atulji also said, that we need a seamless execution of the policies now. What we have applied, we should at least see a flow of it. That will give us the confidence that this can happen, and then we take a challenge on us to move forward. Thank you.
Thank you, sir. Thank you. So my watch says that we have already spent 37 minutes in this discussion. 5-6 minutes more. I'd like to request the audience, if they have any questions, we can take some of your questions. Anybody? Yes. Can somebody please pass on a mic, please?
It's all very good that we start indigenous manufacture of the chips in some time, but the issue which Vinod raised in the morning, that's, will they be price competitive? Can we enforce that Indian manufacturers of equipment will purchase these when ITA1 is still legal and they will be available in the market? So how come our products will be consumed by at least the domestic industry?
Yeah. This question, would you like anybody in particular to be answered?
So go ahead.
Please go ahead. Okay. General Saab, very good question and very pertinent question. I think, yes, we can be price competitive, but not in the beginning. Because in the beginning, we will not have the volumes. As the volumes build up, our raw materials will be supplied at competitive prices, including the wafers. Then we will be competitive. So that's why the PLI scheme, for example, will help us, at least in the initial years, to bridge that gap. May not be completely, but at least partially, PLI scheme will help us to bridge that gap initially. Eventually, we have two advantages. Number one is our labor costs are lower than even China today. Today in India, labor is about $200 a month. In China, you can't get a labor of that caliber and aptitude even at $800. So we have that labor benefit. But more importantly is the engineering talent that we have in the country. And in all semiconductor packaging, it is not only the manufacturing and labor input that goes into it, but there is an engineering input, because you have to constantly, come up with better ways of producing, better ways of testing, make sure your yield is much better. Because in this game, with a high volume game, yield is the most important thing. If you get to 99% yield versus if you get to 99.5% yield, that will make the difference for you being competitive, not only for the domestic market, but for the global market.
I will just add to him. EFAB is the final stage. One is to come to the package and then start the beginning of it. However, first 1 or 2 years will not be price competitive at all. Whatever the current price we are buying will be higher than that, because the raw material, the labor, everything is fresh to start us. As we progress and our mass production increases, however the yield ratio increases, our cost will drastically come down, and we also have an export business which can set off to this, and definitely will be competitive after 2 or 3 years. First 2 years, the consumers, the customers and the industry has to support and bring a synergy, even if it's a little bit high, but we have to start making it here on a larger run.
Just a little, just like to add, to answer your question, it's a very right question, honestly, and my friends here have addressed most of it. I know that if you start buying, you will not buy at 5% higher or 10% higher. I mean, honestly, no EMS company, when working on margins of 5, 8, 10% would want to buy components at additional cost. But our request, what in the morning Vinod was also touching, please look at the total cost. Total cost means if you're buying from a country, neighboring country, you will have to order 2 months in advance. There is something that's coming on the way, which is a WIP moving on the way. There is some stock that you're holding because you're worried that your lines will come to a halt. And you have payment terms with those countries that many a times they are advance payments before shipments. Please total up the complete cost to you. Please do not look at a price of 60 paisa and I want 55 from you. Honestly, if the purchasing department looks at the total cost to him, including the cash blockage there, and then looks at the cost from a company in India delivering him the goods every week or every 10 days, his total cost is going to come down. Please do not compare 60 paisa to 55 paisa. Please look at 55 paisa has additional cost to it, custom clearing cost, your other costs involved, your logistics cost. These days you don't even get carriers bringing in goods to you. There are no ships available. There are no cargo ships available. The freight costs have skyrocketed. Add all that to your cost of the product and then come back and show us a chart, and I'm sure we are competitive. Because we are exporting today to Europe and US. If we can export to Europe and US and fight the same neighboring country there, why can't we do that in India? So please look at it as a complete cost to you rather than just A to B. Thank you.
Brilliant, sir. Brilliant. Thank you. General Sahab Trust addresses this question. Yeah. Yes, please.
So, I'm Ashok from Salcom. Thank you so much, sir. It's a good insight about like semiconductor, at least to the starting in India. Couple of points like this. So price competitiveness, yes, you have addressed it beautifully. The other point is like this economy of scale. So again, it is a chicken and egg story. So what are basically the plans? Like how will you enter into we have the global OEMs here in India. So enter into their supply chain because they have the semiconductor is again the part where like the quality level, the kind of reliability which is like your final product is mostly depend on basically the type of semiconductor which you use, the quality of semiconductor. So how will you really enter into those global OEMs into their supply chain? Until unless that happens, this economy of scale will not come. So that's the point number one. And of course, like then, is there any plans to really start not only for India and then going forward in 2 years or 3 years down the line, do you have some certain plans for the export as well, just to get the economy of scale? Thank you.
Wonderful questions. I know because coming from Salcom, I can understand that. As far as entering into the global supply chain, even Salcom is a global manufacturer for us. And my request there would be that in all these global supply chains, there's a procurement head. Please give him the flexibility to at least evaluate the semiconductors. I know a lot of semiconductors are lying in the drawers of lot of MNC companies and still not even evaluated or approved. It goes way down their evaluation cycle. So unless that initiative, sir, has to come from the MNCs, from the large companies as a KRA to them, that please make sure that you indigenize, if not 50%, 10%, 5% every year, and throw a challenge to the manufacturers. This is what Vinod was saying, throw us a challenge. If we do not meet, okay, then we'll not come back to you. But if we can meet all the AECQ standards, all the ISO standards and supply to the automotive companies of the world, why can't we do that in India? Throw us a challenge. So that KRA has to come from the MNC. Your second question was on the global, now as a company, now I can only talk about my company, our schemes of PLI inspects that we've got approved, we are not looking at the India market to begin with, because that's extremely difficult. The volumes are not there to justify a plant investment for India market. Our focus is the international market. We have discussed with the customer, their volume indications we have. We are delayed by 1.5 years, but the customers are still talking to us. There's a certain volume that the international market demands. So our investment is based on the international market and India market would be an initial feed, but the plant investment is always based on the international, otherwise economics of scale will kill us, we'll be nowhere in terms of semiconductors. Right, sir? Thank you.
Thank you. I can take a couple of more questions, if anybody has any questions. Please.
I'm the president of IT.
Please use the mic, sir.
Especially most of the colleges, engineering colleges, we established. Leaving the IITs, we have got these kind of facilities. But most of the colleges we don't have. So first of all, you must encourage the engineering colleges to have this, even though theoretically it is being touched upon, at least at MTech level and other things. But practically no lab facilities exist. So skilling is missing in a way. We need, and we have a very large number of engineering colleges, so that we can train our people. And secondly comes to skilling, definitely that part is added. And I must say the focus on the startups. If we focus on the young people, and India, we have got a very young people, is very focused people these days. So good examples are happening at IIT Madras or other places. Things are working. It's not that it's not working. But we push to the other institutions, academic institutions, other, maybe at IIT level or politically also, so that we can give a skilling at a low level and startups coming up. This is what. Thank you.
I just touch upon this on one point. The cluster semiconductor is what we want to say. Here I have made a note what has happened in Vietnam. It is a design, fabrication, testing, package, plus an university, where they have set up that kind of a system. Whoever passed out from the university, they get a job there, who is interested in testing, who is interested in quality, who is interested in production, who understands and develops. So what I said is semiconductor as a fundamental electronics should be a course by itself in the college and universities to take it forward, and then could happen. So this is one good thought where we can make an ecosystem of a cluster, a company can setting up, like how Infosys has its own kind of a system. Similarly, we can adopt in the semiconductor hardware as well.
Yeah, I'll just add a few points to that. And again, very, very pertinent point that you raised. What Electronic Sector Skill Council is doing is that they are defining job roles, various job roles, whether it is for wire bonding or die bonding or grinding or testing, etc., etc. So they are developing QPs and defining job roles and preparing courses. So Electronic Sector Skill Council under Ministry of Skill Development and Entrepreneurship, they are doing just that what you suggested. Now what they are doing is they are taking people from ITIs or diploma holders or even lower, 10+2, and at various levels, level 2, level 3, level 4, they are skilling people. And that will go a long way ultimately to develop a skill ecosystem. And therefore, when the industry is ready, we will be able to give them jobs. That is number one. But the second point, as you rightly said, besides the job roles for manufacturing, what is very important is at the design level. We have to become, at least initially, we have to be a fabless country, because fab is going to take time. So on one hand, we have to do the designing here, and then at the back end, we have to package the product. That way, we will not be dependent again. If the product is designed here, then we are not dependent at all on foreign companies to be able to give it to us. So that is very important. Let's understand, there are many companies, including Western Digital, including Motorola's, GEs of this world. They have a huge design centers here where they engage, or ST Micros and Infineons. They have more than 3,000, 5,000, 10,000 engineers who are doing nothing but designing. But if we had people doing designing here, having their own IP, that will become very important. That will take the country forward.
Thank you, sir. Thank you. I think we have overshot our time now. One last question by the gentleman, please, and then we'll wind this.
Yeah, myself, Gudi from Samsung. I just want to ask, we are talking about packaging and designing of, the semiconductors. What about the back chain of raw materials? like silicon, gallium, and that. Are we talking about those? Because otherwise we'll be again dependent on foreign companies. Just packaging here, designing will not solve the issue of integrating end-to-end solution of semiconductors. So are we going to see that also? Or we are just talking about again assembly?
No, I'm sorry. You know, sir, we explained to you the whole semiconductor chain, value chain is wafer fab,
Yeah.
and then assembly and the test part of
Yeah.
it. So wafer fab we are keeping out at this point of time because that's like billions and billions of dollars of investment and very specific, depending on what segment you're going to go into. So the balance area remains as the assembly and the testing part of it. So when you talk of other compounds, silicon is being done. The other wide band gap or other semiconductor that's coming in is the silicon carbide for the electric vehicles. Now as a company, CDIL has already started the prototypes for making the SiC diodes, silicon carbide for the export customers, again export customers, because we start with the export customers. So that technology is also moving in, and that's part of the government scheme also in the 76,000 crores incentive scheme of the wideband semiconductors. That is starting, but wafer fabs are, I do not see the fab coming in like what they've said for a couple of years from now. That's the thought. Although government wants it next tomorrow, but it's a thought that I have my personal views. Okay.
Thank you.
To begin with, wafers fabs is the last stage of any semiconductor. Right. As both all of us has said, assembling and package, the back end has to be done. Now or later, maybe another 2-3 years, if we had to depend on the raw materials to get from them, still it is okay to make a beginning, rather than just having a discussions and things like that. So having said that, in terms of making the raw materials required to make the end product may take 5 or 6 years. But however we start and get hold of these techniques to begin with, that's a very big beginning. That's what I also strongly feel.
Thank you. You have a question, sir? You have a question. Go ahead, please. Somebody give him a mic. That's the last one, right there? You are the one.
Yeah. This is the last question, please.
Yeah, I'm sorry, sir. I know that the time is flicking out. There is a one simple question. My name is Sanjeev Kher, and I'm from SGS. So I have been attending this seminar, some time ago also. So a lot have been done by the government in the terms of infrastructure. Because earlier you see the importing consignment and everything. So got stuck. There is a lot of improvement. So now the clearance time and everything has been smoothened, and there is a much improvement. So now coming on the first is the this foundry and fab. We understand there is a huge kind of investment. So now if we come to the PCB, which is a very very important ingredient part for the electronics. So for the PCB also even, the whole raw material, our dependency is hugely on China.
That's a different subject altogether, sir.
No. My only question is, it is related to the electronics that is I am coming to. And like in the electronics also, if we go to the metal film capacitors or electrolytic capacitors, the whole raw material is coming from China. Even in the, in Deki also, probably I feel the raw material is also coming from China. Yeah. If we do not attack on the raw material, so we